All right, guys. Here's to maybe one of the last videos we're going to make with our gas laws and understanding how to use the different types of gas laws to find either pressure, volume, or temperature of a substance. And so we're going to take a look at Boyle's law. Boyle's law takes the initial pressure and the initial velocity, and it is going to be equal to the final pressure and final velocity. P1 V1 equals P2 V2. Again, just as a review with pressure, atmosphere is the standard pressure that we typically use. It could be millimeters of mercury, it could be psi, it could be kilopascals, torr, etc. From there, when we're starting to look at volume, we're looking at things like milliliters, liters, cubic centimeters, cubic meters, those kinds of measurements from there. As long as the measurements are set up equally and that you're solving for the same measurement, then you should be fine with Boyle's law here. So let's just kind of take a look at an example of that. We're assuming that temperature is remaining constant. So if the temperature is constant, then all we have to do is take a look at how does the pressure and the volume change. If I increase the pressure, what happens to the new pressure, or what happens to the new volume, etc. from there. So if we take a look at, maybe I have a balloon, and it started out at 1.1 atmospheres, and it had a volume of 2 liters, and I wanted to know what would its pressure be if I changed its volume to 4 liters, or if I doubled the volume from there. So we just set up our equation as it is written. P1 V1 equals P2 V2, and from here we do our simple algebraic expressions here. We've got 4.0 on this side. We want to get P2 by itself, so we're going to divide by our 4 liters on this side. Whatever we do to one side of the equation, we have to do to the other side of the equation. So we're going to divide out here by our 4 liters over here. That is good because those will cancel out. That leaves my P2, which is what I wanted to know, by itself. The nice thing here is my units of liters are canceling out here, leaving me with just atmospheres, which is what pressure should be measured in. So if I take my 1.1 and I multiply it by 2, I'm going to take that and now divide it by 4, and I should get an answer of 0.55 atm. So that should be my new pressure. And that makes sense because our pressure and our volume are going to be inversely related to each other, meaning if I am increasing my volume, going from 2 to 4, in order to make the equation work, I must decrease my pressure. And I went from 1.1 to 0.55. I doubled my volume, therefore I have to decrease my pressure in order to keep that system going. Again, this is kind of simple Boyle's math at its finest, just to give you kind of a review of what we're doing and how to solve for those equations. If you have any questions, let me know.